eventually added the electric field. So first part we discussed. We were on the second part. This point is a little separate, is at a little separation from this vertex of the triangle. This separation is 0.05. So I have written it again here. This separation is 0.05 meters. This is 0.1 meters. The charge positive, this is the negative charge, and this is B point. So when we take out the directions, see, due to the negative charge, electric field is electric field is directed towards the negative charge. And the positive charge, due to the positive charge, electric field is away from this positive charge. So since we can see electric fields are acting in the opposite direction, we will say that the net electric field will be E1 minus E2 because the angle is 180 degree. So we can now subtract the electric fields. In the first case, we added them. Now we are subtracting because the directions are opposite. Now E1, let's take the smaller distance because smaller distance will lead to a larger electric field. So this is the small, and we have seen the graphs also that electric field is inversely proportional to distance. So see, first we will use K, then we will use the charge. I'm talking about this positive charge which is separated by 0.05 meters from B. The charge is 10 to the power minus 8 divided by, this separation is 0.05 whole square. Minus, what is E2? E2 is the electric field due to the negative charge. This total is the electric field. That is K into 10 to the power minus 8 divided by. Total separation is now 0.05 plus 0.1. So total separation becomes 0.15 meter whole square. So see, we can take this K and this charge out. 9 into 10 to the power 9 into 10 to the power minus 8 out. And we'll be left with 1 by 0.05 whole square minus 1 by 0.15 whole square. So this much Newton per coulomb is the electric field. This you can calculate later. Now the third charge is left, that is this C point. This is left, E1, E2 and E. So if you look carefully, class, E1 is the electric field due to the positive charge, this one. See, charge is 10 to the power minus 8, separation is 0.1. And look at E2. E2 is the electric field due to this negative charge. But when we take the magnitude of the charge, it is 10 to the power minus 8 coulomb. And separation is also 0.1 meters. So if you see here, both the electric fields will have the same value of electric field, right? K Q by means K into 10 to the power minus 8 by 0.1 whole square. Here also K into 10 to the power minus 8 by 0.1 whole square. Means both the electric fields are same and they are separated by 0 degree. So this is the point C. Now C is, this is electric field E1, this is electric field E2, and their angle is 120 degrees. See, E1 and E2, both the magnitude is equal to K into 10 to the power minus 8 by 0.1 whole square, right? 0.1 meters whole square. So let me, instead of writing this, let me write it as E for the calculation. So the net electric field will be given by under root, see, E1 square plus E2 square plus 2 E1 E2 cos theta using our parallelogram law. Now electric field is the same, magnitude is the same. So I can write E square plus 2 E into E is E square into cos 120 degree. What is cos 120 degree, class? Minus half. Okay, this is minus half. So 2 gets cancelled. Look, under root 2 E square minus E square. This is equal to E square under root, which is equal to E. So what was our E? E was 9 into 10 to the power 9 into 10 to the power minus 8 divided by 0.1 meter whole square. This much of Newton per Coulomb. And see, the resultant will be pointed like this. This will be the resultant. The net electric field will be pointed like this. So you can take beta with any of it, and you can calculate tan beta for the direction also. Tan beta becomes B sine theta divided by A plus B cos theta. So A is this one E, B is this. But right now both the electric fields are the same. And see, when you put E sine 120 degree by this is also E plus E cos 120 degree. Like this, when you put eventually the electric fields will be cancelled. But I'm not solving it till here. I'm just telling you the further direction part when you have to answer. So this is actually a very lengthy question when you see, because you have to calculate everything in this question. Okay, so point A you have written. Please start writing from point B and for point C also. Is that clear, Ibrahim and Jasleen?
Yes, ma'am.
Okay, please write it. Okay, class, let's start with the dipole moment concept. So see, for understanding dipole, we should understand what is meant by monopole first. So monopole, from the term, it's very clear when we use the term mono, it means single. And the term pole is used for polarity. So when we say monopole, monopole means system that have only one charge, one kind of polarity. Like if I talk about electrons, electrons are those species that have only the negative charge on them. So this is a monopole. Or if I talk about proton, proton is that element that has only positive charge on it, right? So these are what? These are the system having only one type of charge, either positive or negative. And what is monopole moment? Whenever this term moment come, it means we are talking about the strength. The strength of the dipole. When we are talking, this is the strength of the, sorry, not dipole, the strength of the monopole. That is called as the monopole moment. Okay, the strength of the monopole. So we have already studied this in the additive property of charges. Like if you have a system and one monopole is, let's say, plus 2 coulomb, one monopole is plus 3, minus 3, one is plus 3, randomly I'm taking. So when you are calculating the net charge, it will be plus 2 coulomb minus 3 plus 3. So these are getting cancelled. This is plus 2 coulomb. So these are individually the monopole systems, right? Plus 2 is a positive element, minus 3 negative, plus 3 positive. Now, what is a dipole? Di means two, pole means polarity. But this does not mean any two polarities together. For a system to be considered as a dipole, there has to be a criteria to follow. We say two charges should have same magnitude, means if I am taking one as Q, the second charge also has to be Q only. But the signs have to be opposite. Means if this is positive, this will be negative. So one positive charge, one negative charge. This is how your dipole is made. Okay, and they are separated by a small distance. This is what is a dipole. For example, you have H plus ions and Cl minus ions. This forms a dipole. So that's why you have dipole moment in chemistry also. See class, you cannot have a dipole like this, plus 2 coulomb and minus 4 coulomb. This won't form your dipole. Or I cannot take plus 2 coulomb with plus 2 coulomb. This also won't form the dipole. If I am taking plus 2 coulomb here, here it has to be minus 2 coulomb, then only I will say this is forming a dipole. So any two charges cannot be taken. If we are considering a system of dipole, we have to consider two charges with the same magnitude and the opposite signs. Now, this is what is meant by dipole. When we come to dipole moment means like your monopole moment, we have dipole moment. Dipole means the strength of the dipole. How you can calculate the value of this dipole. So formula is very simple. First, you need to understand how the system is made. Remember, plus Q and minus Q are present, and they are separated by a distance that we consider as 2a. 2a does not mean you are doubling their separation. 2a means you are taking the separation between the charges. So how to calculate the dipole moment? It is represented with this P. You take the magnitude of any of the charge because both the magnitudes are same. You take any of it, let's say Q, and multiply it with the separation of the charges. What is this? Let me tell you again. P is the dipole moment. Q is the magnitude of the charge. And 2a is not doubling the distance. You just need to check the separation between the charges. Whatever it's given, that will be your 2a. It's given, if it is given as 8 meters, your 8 meter will be 2a. You don't have to write it as 16. If it is saying half of dipole, means a, your half of dipole will be a. So what is 2a? This is the separation between the dipole. What all things you need to know about the dipole? See, first of all, by this symbol, it's very clear. It's a vector quantity. And when we talk about vectors, we always have direction. So look, remember, because this is there in your chemistry also, so it can be confusing. Direction is from the negative element to the positive. This is the direction. In your chemistry, it will always be towards the electronegative element. So you can get confused. So just keep it in mind. This is different in physics and chemistry. From the negative to the positive charge. Now, coming to the SI unit. Yes, class. Can anyone tell the SI unit by looking at the formula? What should be the SI unit of dipole moment?
Ma'am, won't it be coulomb meter? Coulomb meter,
Yes,
yeah.
correct. Ibrahim, right. Charge is coulomb. 2A means the separation. So this will be coulomb meter. Correct, Shaima. It will be coulomb meter. So this is what is there in your dipole moment. We'll see two questions, one very easy and one little tricky question that can come. And then we have to relate it with electric field. So please write it. Class done?
Yes, ma'am.
Okay, let's see a question based on this, a formula-based question. See, this question says two charges, one plus 5 micrometer and another minus 5 micrometer are placed at 1 millimeter apart. We have to calculate the dipole moment of. Okay, so formula of our dipole moment is Q multiplied to 2A. Jesslyn, what's the value of charge that I should put? Complete value of charge? Yes, Jesslyn? Yeah, 5. That's it. Yes, Jesslyn, answer. Five is not the charge, complete charge that is given. What is the value of the charge? Yes, Jesslyn. You're not audible, Jesslyn. Please fix your mic. Type in the chat column at least. Yeah, what should be written? 5, that's it. Microcoulomb. So I should write this as micro. This is what you write. This is how you will solve this question. You have to convert micro also, no? You cannot write micro in your solution. Yes, Jesslyn, answer quickly. What should we multiply to make it in SI form? This is not, you cannot write micro in your answers. And please, Justine, get your mic also fixed. I think there is some issue because whenever you're trying to answer, the volume is coming very low. This is the final answer, no, Shaima?
Yes, ma'am.
Okay. Yes, Justine, right. 10 to the power minus 6 into 10 to the power minus 6. Shaima, what should we multiply next? With
The
this?
distance.
Yeah, what is it?
2 into 10 to the power minus
Why?
3.
Why 2?
Because it's written 2A.
It is 2A. And what did I tell you? What is 2A?
The distance.
Separation between the dipole. Means the distance separation between the two charges. And I specifically told also don't double it. 2A is the separation. Means if the charges are separated by 1 millimeter. Right. So your 2A will also be 1 millimeter only. That's why your answer was wrong. Okay. It won't be 10 into 10 to the power minus 9. Because your separation plus 5 microcoulomb and minus 5 microcoulomb, they are separated by 1 millimeter. So your separation will be 2A only. 2A is the separation. You don't have to double it. That's what I was telling you. This will be into 10 to the power minus 3 meters. Okay, and this final answer will then be 5 into 10 to the power minus 9. Right now, nothing is given, so let's write this as coulomb meter. Figure is not mentioned like this. Now I hope it's clear to all of you what is the usage of this 2A. It's not to double it. Okay, quickly write it. One more question we will see. Class done?
Yes, ma'am.
Okay, this is the same question of dipole moment only, but this is given in a coordinate form. Like it is provided on the coordinate system, your axis. So these are the two charges plus 2 millicoulomb and minus 2 millicoulomb. And see, this is their coordinate. These are their coordinates. Okay, 0, 0, 2. Here also 0, 0, 2. So we are going to put the formula. We know the formula is P is charge multiplied to 2A. Ibrahim, you tell me what is the value of charge that I should put?
Charge.
Yeah.
Microcoulomb. So 2 into 10 power minus 6. Yeah, I think.
Is it micro?
Is it? Oh, no. Micro is another. It's megacoulomb. Is it megacoulomb?
Milli. See, micro
Oh,
is
milli.
this.
Okay. 10 power minus 2.
Mega is capital M. This is 10 to the power minus 6. This is 10 to the power plus 6. This is milli. Small m means milli.
Okay.
Okay, so yes, Shaima,
10
correct.
power minus 3, I presume. Yeah. 10 power minus 3.
Correct. Shaima, now can you tell me the distance between these two? 2A. What should I write as 2A?
2 into 10 to the power minus 3.
2 into 10 to the power minus 3. Jesslyn, what do you think? See, 2 is the coordinate 1. Yes. C class. Coordinates are always given from the origin. Okay, they are always given from origin. Means if this is minus 2, it means from the origin, this is the separation. This is 2 millimeters from here. But when we are calculating complete 4A, this will be 4 millimeters. So right. So 4 into 10 to the power minus 3, which is equal to 8 into 10 to the power minus 6. Jesslyn, at least tell me the direction. Towards which axis? Yes, Jesslyn, towards which axis? Is Jesslyn audible to others or is it just me? Is she audible to others? Shaima Ibrahim, are you able to hear her?
No,
Yes,
ma'am.
ma'am.
Ibrahim says yes, Shaima says no. Jesslyn, you type. And please check once in the audio settings of Zoom. I think you connect the headset, no? So you have to choose something, select same as speaker or whatever. It might be due to that. Just check it once. But till the time type. Shaima answer is right. Towards which axis, Jesslyn? Yes, so Shaima, you are right. Positive z-axis. From the negative to the positive charge. So when we are calculating, this will be the direction of the dipole moment. So this is towards positive z-axis means we can write k cap coulomb meter in order to show its direction. Positive direction, right? But z-axis, z-axis specifically, because positive x and positive y are also present, okay? And this time we are talking about only z-axis. All of you, please write this question. And we'll then start with electric field and dipole. Yes, Shaima. If it is negative z axis, then it will be minus k cap. Done?
Yes.
See, this is what I was talking about, Shaima. X-axis is I cap for positive right, plus and negative. Y j cap, positive right plus, y negative. Positive for z-axis we write k cap. So for positive z-axis, write plus k cap, and negative right minus k cap. More than this chapter, we'll be using these in the magnetics chapter. Magnetism requires a lot of direction. Now see what is meant by this axial line. Axial line means a dipole is present. See, 2a is the separation between the dipoles. So a will be half of the dipole. And when you extend this axis, if the point where you want to calculate the net electric field due to this dipole is lying on its axis like this, look like this, then this is the axial line of the electric dipole. Now we require one thing because here it's missing. If you look for this charge and this charge, what we are going to take from the center of the dipole to this point P, we are going to take a separation that is R. What is R? R is the separation from the center of the dipole to the point P of calculation. This will be used in your equatorial also. So axial, how to check axial line? Because when you have multiple questions, sometimes it will be confusing. See, wherever you see the point is present on the axis in whichever direction, but it's lying or intersecting with the axis, it is your axial field. Now we are going to write down the electric field due to this point. Now, see, due to this positive charge at this point, electric field will be away. Look, E due to positive Q. And because of this negative Q, electric field will be attracted towards it. So electric field due to negative charge. Now, we are going to write down the magnitude first. Then we will calculate the resultant. If you remember, this is just a similar case of the B point, which we did in the starting of the class. Remember, minus 10 to the power minus 8 and plus 10 to the power minus 8 coulomb, separated by 0.1 meters with a point 0.05 situated B point. So that question can be solved with this. That was the axial line case I told you also. Now, when we are calculating electric field due to the positive charge, Ibrahim, can you tell me what will be the magnitude? Positive Q. This is the point.
On P, E is equal to KQ by R square. Yeah.
Yeah. So K is there. What's
K
the charge?
times positive Q. A
P.
plus,
All.
no, wait, no.
Listen,
R minus
Ibrahim,
A.
never say positive or negative. When you are calculating the Coulombic force or the electric force, we always take the magnitude. So it will be
Okay.
simply Q
KQ
divided by.
divided by R minus A, the whole square.
Correct. This total is R. This part is A. So this
Yeah.
leftover will be R
R
minus
minus A,
A
the whole square.
whole square. Correct. And Ibrahim, you only tell me for the negative one also.
R same divided by R plus A, the whole square.
Correct. This separation is R. And see, this extra part is A. So total separation from the negative charge will be R plus A. So KQ by R plus A whole square. First, tell me, all of you. This is clear? Jesleen, Shaima, both of you have understood till here? No doubts?
Yes, ma'am.
Okay. Now we are going to calculate the resultant electric field. For the resultant electric field, we have the directions with us, right? The directions are opposite. So basically we have to subtract both of them. Correct. So resultant electric field at point, this net electric field will be E due to plus Q minus E due to minus Q. So this will be KQ by R minus A whole square minus this will be KQ by R plus A whole square. Now let's take KQ common. So see, what are we left with? If we take KQ common, we are left with R minus A whole square minus 1 by r plus a whole square. Now see, we just have to solve the brackets and we'll get our value. Look, KQ I have taken common. These are the two brackets. So if we take the LCM will be r minus a square into r plus a square. So this side we have to multiply it with r plus a square minus this side we have to multiply it with r minus a whole square. We have taken the LCM. Now this is a plus b whole square. This is a minus b whole square. So we'll be applying the identity. This is KQ. Look, a plus b whole square. A square plus b square plus 2ab. Correct? Minus. Now this has the minus sign. So let's write it reverse. This has to be r square, but we'll write it as minus r square. This has to be plus a square, but due to this minus, it will become minus a square. And then we write minus 2ab, but due to this minus, minus into minus will become plus 2a, b is our r, divided by. See, this is, if you can identify, this is the identity, a plus b into a minus b is equal to a square minus b square. So look, this can be written as r square minus a square to the power whole square. Tell me, till here all of you are clear?
Yes.
Okay. So look, r square, a square gets cancelled. So finally, we are left with k, q, 2ar plus 2ar becomes 4ar divided by r square minus a square to the power whole square. Now class, 4 into a can be written as, this 4 into a can be written as 2 into 2a. So I'm just rearranging the terms. Look, k, q into 2a into 2. See, 2a into 2 is giving 4a back into r by r square minus a square to the power whole square. Can anyone tell me what is this?
Dipole.
Yes, dipole moment, correct. So this is P. So finally, our answer will become, the formula that we have got will be, this will be equal to K into P, okay, KP, 2 KPR by R square minus A square to the power whole square. Now direction and ideal dipole approximation I'll tell you later. First you write down this derivation. And remember, these derivation do come in the board exams. In one set they give axial, in another set they give equatorial. Like this, they often give these derivations from electric field. Because numericals are usually given from Gauss law and derivation is given from this. Okay, write it till here, then we'll complete the derivation. Shaima, one more thing. When will you appear for the test? Because I have to discuss the test paper with you. 1 or 2 questions were difficult, which all of you, most of the students have found difficult. So yes, Shaima, when you will appear for it? This week?
Ma'am, I don't know. Learnivio did not ask me about that.
Yes. Yes, Shaima, what were you saying?
No, I'm not sure when to attend because Learnivio, the team had not contacted me about that.
You didn't know about the test.
No, I knew about the test, but they didn't like for a retest. They didn't tell me when to, which days
Okay.
I can.
Okay, you can give it. You can give it. I'll just tell them to tell you again the instructions, okay? Because I was waiting for you and Zainab only. Only you both have not attempted. Class done? Okay. C class here. Now the direction. So we know the direction of electric field for a positive charge is away from the charge, negative charge is towards the charge. But in this case, when you have the dipole present, means positive and negative are present together, then how you have to calculate? So you look whether it's axial or equatorial. Value of form, formula with the value of k, both are right, both are actually true. Means you're saying instead of k 1 over 4 pi epsilon naught, no Zainab? Sorry, Shaima. This is what you're saying?
Yes, ma'am.
Yeah, that is, this is a part. See, I am writing k. This means I'm assuming that we have already discussed k is 1 over 4 pi epsilon naught. Once writing this, I will show you in the ideal approximation, I was about to write the same thing. You can write, you have to write. This is what is k. K's full form is the whole value is this only. Now, when we're talking about the direction, remember, it is exactly the same as that of dipole. Like, look, we move from the negative to positive. This is the direction of dipole. Direction of dipole here is towards the right. So electric field will also be towards the right due to the dipole. Same thing. Same will be the direction for the electric field. This is one thing that you need to remember. Second is the size of dipole. You have ideal dipole approximation. Means the size of dipole is very small. What does this mean? Look, if I say size of dipole is small, means this is minus q, this is plus q. This separation is very less. This 2a is very less. The dipole is very small. But the point is located at a good distance. So if 2a is so small, a is half of it. A will be further small. So what happens eventually? R, which is the separation from the center to the charge, becomes very much greater than A. So in the denominator, if you see, we wrote R square minus A square to the power whole square. So R square, a bigger term, and you're squaring it like 1000. Minus, you're taking a smaller term and you're squaring it like 1 square will be 1, like this. When you're subtracting, it is 999, which is almost equal to your 1000 back. So in a big thing, from a big thing, you're just removing one drop of it. It won't harm it. So if you see the dipole separation means this small, if you see in the question, R is greater than A, they are not comparable. Like A is given as 1 millimeter, R is given as 3 meters, like this. From this question, from the questions, you have to identify like this. Then you can equate it to R square only. This A will become negligible. What's the use of this 1 in front of 1000 or 10,000? So what we do, we write the denominator as R square only. What was the formula that we obtained of electric field? We obtained 2kpr by r square minus a square to the power whole square. Now instead of this, I am going to write just r square. So 2kpr by r to the power r square. Now I have this square. So that makes it 2kpr by r to the power 4. This r will cancel this power and make it cube. So see, what is our final electric field? Electric field due to the axial line. This will be equal to 2kp by r cube. This is the formula. And we write the value of k as, which is 9 into 10 to the power 9. This is written as 1 over 4 pi epsilon naught. So 2p by, this becomes 4 pi epsilon naught 2 k p by r cube. This you can cut further also, which will become p by 2 pi epsilon naught r cube. All are the same. You should just remember k is the same. So k will have the value. K is 1 over 4 pi epsilon. This is it. Okay. So complete it. Then we will see equatorial if time is there. Write it from here. Okay, the next is equatorial point. So equatorial means the point is situated at a distance of 90 degree, means at an angle of 90 degree. So this is what is called as equatorial. Now, again, we will take, see, we are going to take R, the definition of R will be the same in both the cases. R is the separation from the center of the dipole to the point of calculation, correct? This is R. Now, see, this point P is separated to this minus Q, and this is separated by plus Q like this. So here at P, we have to calculate our resultant. They both are separated by 2A and half of them will be A like the previous case. These are the changes. Now look, when we are calculating the electric field, negative charge, and this is our point P, this is the negative charge. So due to this negative charge, the electric field will go here. This is the electric field due to the negative charge. Direction is away. Sorry, this is towards. This is negative charge, so direction will be towards the charge. This is the negative. And due to positive, it will be away. So if this is the line of sight, so this will be exactly the direction of the charge, E plus Q. Now the problem here is, class, these electric fields, these are not along X or Y axis. So we need to perform resolution of vectors in order to get the net electric field. So we have to resolve it like this. This is your X axis and this is your Y axis. So this way we have to resolve it. And this is point P. So look, class, let us say this is angle theta. So this will also be theta, alternate angles, and this will also be theta by symmetry, right? Now, after applying the geometry part, we have to come back to our physics part, that is resolution of vectors. So see here, we are resolving E minus Q. Due to E minus Q on this axis, what will be the component, Shaima?
Yes, ma'am.
What will be the component?
Cos theta.
E due to -1 cos theta, right? And the perpendicular one will be here, E minus Q cos theta. And look, this is E positive Q. So again, due to this also, this axis will receive cos theta. So it will become E plus Q cos theta. And this perpendicular one will become cos theta, right? So now, Jesslyn, can you tell me what all vectors are there along y-axis? Which vectors? How many? At least tell me the number quickly. Two vectors are there. Look, this is E plus Q cos theta. This is E minus Q cos theta. So sorry, this has to be sine. So E minus Q sine theta and E plus Q sine theta. So sine components are along the y-axis. Yeah, two vectors, correct. And here also two vectors are there. But look, these are in the same direction and these are in the opposite direction. So what will happen when you are calculating the net electric field due to y-axis, and you will calculate the net electric field due to x-axis separately, okay? So E due to minus Q, don't write E due to minus Q means this charge. So look, the charge, the formula will be K Q divided by. Now, can anyone tell me what should be the separation? This is R. Yeah, Ibrahim.
Ma'am, root of r square plus a square, is that right?
Correct. Root of R square plus A square, right? C class. This is the triangle. This is A, this is R. So the separation between the charges, R square plus A square. So once we write the electric field, this will be KQ by under root R square plus A square whole square. Similarly, electric field due to positive charge. it will also be the same, kq by. Now look, the separation here, this is also separated by under root r square plus a square, same separation. So we have the net electric field as under root r square plus a square to the power whole square. Now, you can notice magnitude of electric field are the same here. Magnitude is the same. So if magnitude is the same, when we are calculating the net electric field along y-axis, E sine theta, I am writing both the electric fields as E because magnitude is same. E sine theta minus E sine theta. They will cancel each other. Net electric field will become 0. Now what do we require? We require the net electric field along x-axis. So net electric field along x-axis, if you can see here, both the electric fields are getting added in the same direction. So once you are writing, you can say the net electric field here is E cos theta plus E cos theta. So net electric field will be 2E cos theta. Now value of E and cos theta are required by us. Value of electric field is kq by under root r square plus a square whole square, and cos theta is missing. Okay. So class, time is up. This writing part and completion of derivation we'll do in the next class. I'll give you time to write in the next class itself once we complete this. See, Monday's assignment on superposition of electric field. Okay. And today's assignment. Today, I'll just give you 2 simple, easy questions based on dipole moment. I'll not give on axial and equatorial. This I'll give in the next class. But these 2 assignments, please complete these assignments so that on Monday we can discuss them. Otherwise, we'll have 3 to 4 assignments to discuss.
Can you repeat which assignment?
Superposition principle or due to electric field, Monday's one, and today dipole moment. These 2. And Shaima, you please tell Zainab also, both of you attempt the test so that I can discuss the test paper. I think Ibrahim didn't receive the test because he was added in the batch on Monday itself. Okay, class, time is up. You all can leave now. Thank you so much.